to understand set notation and sets of numbers for our first lesson today. So in terms of a set, it's a collection of objects. So over here on my Venn diagram, we can see that in set A, we've got 3, 4, but we've also got 0, 1, and 2. Whereas in B, I've just got 0, 1, and 2. So we can say that 3 is an element of A, and we use the sign of the element sign. I can put a line through it, and it means not an element. So 3 is not an element of B, because I can clearly see it's not in my B circle. Because the whole circle of B is in A, that means that we don't have an area where B is not. For instance, if I had a normal Venn diagram, A and B. So we know when we're not going to have B on area that is not part of it. So we say it's a subset of A. Now, in terms of unions and intersections, we just need to be mindful of the understanding of relationship. So if we just focus on intersect, this middle area is saying A intersect B. It's part of A, but it's also part of B. The outside area is part of B, but it's also intersecting with not A. Then over here, the part of A is also intersecting with not B, and outside is intersecting with not being A and not being B. If I just wanted the whole middle area of my Venn diagram, I could just say that would be A or, so union B. So when the question says A intersects B, it's just referring to your numbers inside, which is 3 and 9. And when the question says A union B, it's saying every aspect of my Venn diagram inside. So everything to do with A, everything to do with B, which is all my numbers. 1, 2, 3, 9, 4, 8, 5, 6, and 7. So I've already put this information into my Venn diagram already. So I've got 3 groups. I've got elements for X, elements for Y, and elements for Z. So this first question is just saying what area is intersecting with X intersect Y intersect Z. That means it must be the middle area because it's intersecting everything every time. So that means I've just got 8 and I've got 12. I'll erase this. Then the next part, it says find X union Y intersects Z. So X union Y is this area here, because this is my X area. So X or Y. I've also got X here, and I've also got Y here. Now, out of that area, what part intersects with Z? Because it must be part of Z. So straight away, I can see this part does. I've got nothing. This part is part of Z, and this part here. So that gives me 4 numbers. 6, 8, 10, and so when we're talking about set difference, it literally just means we're looking for X elements of A, but they're not part of B. Another way we could say that is I'm saying I'm wanting it to be A intersect not B. So straight away here, if I look at that, I'm looking at this area of my Venn diagram, which gives me 1, 2, 4, and 8. When we are putting information onto a Venn diagram, we start off with the smallest number and we slowly put on. So 1 is just in C area. I've got 3 just in A area. Make sure you underline each time, you don't make mistakes. 8 is in all 3, so it's an intersect. 11 as well is in the middle, it's intersects. And I see the next two ones start at 25. So I've got 18, 22, 23, and 24 just in the A area. Now I've got 25 in B and C. So you find the B and C area, that's just that, which is down here. Then they've also got 30 in that shared space, and then B just has 32. So if I say I'm looking for A, elements that are A but not B. So straight away I need to use my Venn diagram here. So that means first I'm just going to color in the A area that is not part of B. So it's all my numbers there, 3, 18, 22, 23, and 24. Then I'll look for the next question. The next question says elements of C but not of B. So I will just go through C, ignoring the area that is part of B, which is just 1. We'll do the same thing here. So I'll start off with the first number, 1, and put that in set A. I've got 3 just in set C and A. Now 5 in A and C. So it's intersecting right in the middle. Then I've got 7 in all 3. I then have 9 just in set A. I've got 10 in B, 11 in 12 in just B, 15 in C, and 20 just in C. So now I'm going to color it in on the Venn diagram as we solve this. So A intersects B. That's saying what area of A is crossing over with B. So it's this area here. So that just tells me it's 5 and 7. The next part, it says 0 to 8 inclusive, so the numbers that are equal to or greater than 0 and equal to or less than 8, or intersect with A. So in A, I'm looking for numbers 0 to 8. So I've got 1, 3, 5, 7. Now, the next one, it says -2 to 10 is not including that. Intersect B. So straight away I'm going to B. I'm going to circle 7 and 5 because that's intersecting between -2 and 10. But this 10 here, it's saying it can't equal to 10, so I'm not circling that. So it's just 5 and 7. The next part is C. It's saying 4 to infinity. It's not including 4 here. And union C. So out of this has got union C. I'm just going to circle in if it's less than that, which is 3. 20, 15, 5, and 7 will be included in this part right here. So then I'm just rewriting it, but instead of saying union C, I'm going to say union 3. So 3 union, then I've got my brackets 4, comma, to infinity. So just remember with our real number system, we've got complex numbers, real numbers, is quotients. So talking about fraction, integers, whole numbers, and natural counting numbers. And we've got a letter associated with each. But we also know that they are subsets. So natural numbers, which is just counting, are also part of whole numbers. So natural is a subset of whole numbers. Integers has all the whole numbers plus it goes into -1, -2, -3. So it is a subset of them. Integers are a subset of fractions as quotients because we can turn any integer, like -2, into a fraction, -2/1. And then quotients are a subset of real numbers because everything below is real number plus it goes into um, ones we can't write as a fraction like pi square root 2. And then all of those are a subset of complex numbers. So when we are describing a set, there's a certain way we need to. So we need to be thinking about it as we do x column, and that is the set of x such that. Then we need to place the condition. So the condition is what is our range we're looking at. So we're talking about x is greater than 0 and less than 1. Then we're talking about x limits are what? So going back to our real number system, what letter are we going to be giving it? Are we talking about all real numbers, all natural numbers, integers, quotients? Then with interval notation, we've gone through this previously. Just remember when we've got a round bracket on either side, it is referring to a greater than or less than sign, whereas the square brackets is inclusive, it's equal to. Likewise, if it says a to a comma infinity, that's saying x is going to be greater than a. It's going to keep on going to infinity. If I've got the square brackets there, it's all it's going to mean is it's going to be equal to. So x is equal to or greater than. The opposite way, same thing. Just this time it's going to be x is less than b. I've made a mistake on this part of the slide because this one here says negative if we need to b, but it's got the square bracket, which means there should be a line here because it should be equal to or less than b. So let's have a go. Intervals on a number line. So when I'm talking about a, I am talking about starting at 2, meaning inclusive of 2, all the way down to infinity. So for b, it's referring to including 0, all the way down and not including -3. So when we don't include it, it's going to have a open circle. See, same thing. We have -1 comma infinity, so it's going all the way to infinity, but because it is a round bracket, it's not equal to -1. On D, we can see that they're both rounded, which means that when it gets to -5 and 1, it will be an open circle. Okay, let's have a go at this one. This one says -4, 1, union 3, and 7. So both of these are maps. So let's just go through them. So the first thing I'm going to do here, I'm starting with my lowest amount here, and it says -4. Sometimes you can do multiple to see where they cross over. So it's inclusive. So I'm going to put it here. It's colored in because I know it's including it. All the way to this part, it says 3 and 7. So again, I start at 3 because it's inclusive. I color it in. all the way through to 7. Okay. Then I'll move on to the next one. It says negative infinity all the way to 0 and including 0. So same thing. I'm going to do a color indirect 0 and my line going all the way through to negative infinity. Then it's got 5 to infinity. So again, it's colored in for 5 and going all the way through to positive infinity. The next one is slightly different because it says intersect. So here it's saying -5, 0, and it must intersect 0 and 5. That's just going to be a dot right here. Because if I just do the whole thing, so that is -5, oops, all the way through to 0, and intersecting from 0 all the way through to 5. Because it's an intersect, it must be both of them, which means the only point I'm going to do on green here, the only point that it's intersecting the lines is on this green one. So the green one is my answer. The next part, I'll do two colors for this one as well. I'll just draw it out first to help me see it. So it says 0, but it's not inclusive this one. So I'll put a big circle there, all the way down to negative infinity. And intersect -8. Again, it's not inclusive, all the way to positive infinity. Where are they intersecting? Well, they're not intersecting at -8 because they can't both be it. So it'll be an open circle there, -8, and it's going to continue all the way down to 0 here, where I've got another open circle. So that's the part that is intersecting. So that will be my answer. I've already got the answers here. Such I must not have. No, this is fine. I'll still go through this anyway. So we can see here when it's saying x is greater than -2 and equal to or greater than 4, we can write it in our within brackets here. So our rounded brackets -2 because it can't equal -2, comma 4, and we've got our square brackets to say it's equal to. And on the number line, we've got our open circle and we've got our closed circle. All of these are what we've already gone through.